Hello, in this video we're going to learn how to solve quadratic functions, or I should say graphing quadratic functions. So I'm going to change that title to graphing. Okay, so in the previous videos we did solving. So in this one we're going to graph quadratic functions. So what you need to know is that the basic standard form of a parabola is ax squared plus bx plus c. And what we want to look at is when you have a quadratic function in this form, we want to pay close attention to the a coefficient of that function. And if it's positive, it's going to tell us that the graph is going to open upward. And what that means is that it's going to look something like this. Okay? It's going to open up like this. Okay? Kind of like a bowl, all right? And the valley is going to be at the very bottom. And if the a coefficient is negative, then the graph is going to open down. So it's going to look just like this. You'll have like a hill in the top, kind of like a roller coaster when you go up a hill and then you peak at the very top. Okay, that's your vertex, and then you go back down. So just think of it like a hill or hill of a roller coaster, something of that nature. So that's going to tell you if the graph opens up or down. So that's kind of like one thing to look at. And then the next thing is, okay, well, if I have a parabola, right, and you graph it on the xy coordinate plane in 2 dimensions, right, the graph can shift horizontally or it can shift vertically, right? So in the next slide, okay, if we have a parabola and we're trying to graph one that looks like this, okay, first of all, a vertical shift is up the y-axis. So, if you label this as your y, and that's your x-axis, okay? So, when you think of a vertical shift, you think of something like this, where you have the function, and then it's either going to shift up, okay? So a plus k is going to be shifting up the y-axis, x amount of units. And then you also have a shift downward, okay? So a vertical shift downward. So think of it like this, the k, okay, this part here, right, that's, if it's plus k, then it's shifting up that many units. If it's minus k, then it's shifting down that many units, okay? So let's say you wanted to graph this function, right? Let's say you want to graph f of x equals x squared plus 1, right? You notice the function x squared, that's the function, and then there's a plus 1 added to it, right? So that means it's going to shift 1 unit up because it's positive 1. So, right, the 1 tells me it's 1 unit up, and then positive means up from up the y-axis, okay? So if I were to graph the original function, okay, let's say I graph the original function f of x equals x squared, it's going to look something like this. All right, and that's basically f of x equals x squared, right? Well, the function in green is x squared plus 1. So you notice the parabola x squared goes through the origin. It's a little bit off there, but it does go through the origin. If I want this to shift 1 unit up, so if I want this to shift 1 unit up, 1 unit up is here, okay? So that means it's going to shift upward like that. Okay, so 1 unit is right here. Okay, so that's a vertical shift downward, upward, okay? And let's look at another one, right? Let's say you had, I don't know, let's say you had f of x equals x squared minus 1. Then that minus 1 indicates a downward shift, okay, of 1 unit. So if you're at 0, 1 unit is here, right? Negative 1. So remember, the red is like your reference point, right? That's f of x equals x squared. So if I'm shifting 1 unit down, then 1 unit down from 0 is negative 1. So it's going to look like this. Okay, it's going to shift downward just like that. Okay, so that's what a vertical shift is, either up or down the y-axis. Okay, so that's kind of one thing. And keep in mind the axis of symmetry. Okay, it's always going to split that parabola in half in equal graphs on each side. So if you look at the axis of symmetry, the axis of symmetry for all of these parabolas would just be like that, right? So let's say you look at the green one. The axis of symmetry is going to split the graph right along the y-axis, because that's where the vertex meets, okay? So to the right of that black line is half of the graph, half of the parabola, and to the left of that line is the other half of the parabola. And notice that it's right on the y-axis. So the axis of the axis of symmetry, okay. If you look at this line, I'll kind of just, let's call the axis of symmetry. And you basically have to tell me what the equation of that black line is, right? Well, that black line is a vertical line, okay? It's going to be a vertical line in this case because it's straight up and down. And if you notice that when you want to find the equation of a vertical line, you got to find out where it touches the x-axis. Well, if you extend that graph downward, right, downward over here, it's going to touch the x-axis at 0. So it's really going to be x equals 0. Because you have to pretend where that black line is intercepting the x-axis. So in this case, it's going to hit at 0. So just something to keep in mind. So the axis of symmetry would be 0. Okay? And that's the basics of a vertical shift. Okay, so let's try this one here. F of x equals negative x squared plus 3. Okay, all right, well, negative x squared, we need to look at the function. What are we graphing? We're graphing something squared, right? So it's not only x squared, but it's negative. Remember, if it's a negative, the parabola is not going to open right side up. It's going to open upside down. And so what we got to keep in mind is that negative x squared really is over here. Okay? It's really at the origin, and then it just kind of bows down. Okay? It's upside down. Okay? It's like a hill. So the vertex, or the very top, is going to be right at 0, 0, right? Where the origin is. Okay? Because it's negative. If it was positive, then it would be right side up, like the previous example. Now, look at the vertical shift. The vertical shift, okay? This is called the vertical shift. And that vertical shift is 3 units up. Don't forget, this is the y-axis, right? shifting up means up the y-axis or down the y-axis. Okay, in this case, up is, going up, up the y-axis 3 units. So we start at the origin, that's where the vertex is, and the vertex is literally going to shift 3 units up. So you just count, you got 1, 2, 3, well, that's right here. Okay, so that new vertex is really 0, 3, whereas this one was right at 0, 0. You know what I mean? And that's right over here. So 3 units up, and then basically just kind of sketch it. Okay. I'm kind of freehanding this, but that's what it looks like, 3 units up. It's not perfectly bowed, but you get the idea that that's what it would look like. Okay? So, the next thing that I want to talk about is a horizontal shift, because it not only can go up or down, but it can go left or right. You know what I mean? Because you're in 2 dimensions here, right? You got the X and Y axes, and so we're in a 2-dimensional plane, so you can either go up, down, left, or right. Okay, so let's look at the next example. Okay, so horizontal shift is going to be a shift within the function itself. Okay, so what we need to look at is if it's a plus k unit inside the function, then it's going to shift left. If it's a minus k, then it's shifting right. Okay? So, you can look at this example, right? Okay, let's say you had f of x equals x plus 4 squared. You notice that the function is something squared, right? So the quadratic function is going to look like this. This is what it's going to look like, okay? And just think of it overall as something being squared, right? So we have x. Think of x squared is your original function, and then we want to graph x plus 4 squared. You know what I mean? And that plus 4 is a shift within the x squared function. So if you were to graph f of x equals x squared, all right, you notice that it's going to be at the origin, and then you notice that the coefficient of x squared is positive. So it's going to basically go like this, right? Essentially, that's what it's going to look like. Okay? But that's not what we want to graph. We want to graph x squared plus 4. And you notice there's a shift here of 4 units. Okay? And it's going to shift 4 units to the left. So you just look at the origin. Okay? Let's see here. Let me use green, sorry. We go here, we go 1, 2, 3, 4. And that's the shift. And so the graph's going to look just like this. Okay, it's going to shift. Okay? 4 units to the left. Okay? And that's it. And that's what that is. Okay? Let's do another example. So let's say you had f of x equals x minus 2 squared. All right, notice the function, right? Something squared, right? X squared. So the function, the original function is going to look like f of x equals x squared. And then we just want to graph x minus 2 squared. We just don't want to graph x squared, we want to shift, right? So that negative 2, okay, is going to be a shift 2 units to the right, okay? So the original function is really like this. If you were to graph just f of x equals x squared, right? And I'll color coordinate the colors of the equation and the graph so you can see it. So the one in black is f of x equals x squared. But that's not what I really want to graph. I want to graph f of x equals x minus 2 squared. That minus 2, I want to shift this 2 units, okay, horizontally. And that minus 2 is a shift to the right. All right? So shift to the right, well, 0, 0 is here, so you go 1, 2, that's 2 units to the right. Think of the vertex, we're shifting the vertex, that's what we should be focusing on. So the vertex originally is at 0, 0, because that's where f of x equals x squared meets, right? Not meets, but kind of like where there's a vertex. And we're going to shift that negative 2 units, well, again, minus 2 units is going to be 2 units to the right, not left. People think, oh, it's the other way. No, it's actually to the right. It's got to be the opposite. Okay? That's the only thing you got to remember. So it's going to look just like that. Okay? So, this right here is going to be a shift 2 units to the right. Okay? So, if that k is negative, then the shift is to the right. If that k is positive, then you shift it to the left. Okay? So that's the basics on vertical and horizontal shifts. Okay? So, we want to make sure that we're okay with that. Okay? Okay. So, and that's all there really is to it, as far as the vertical and horizontal shifts are concerned. All right? Okay. Let's look at another example. Now let's say you had this function right here. So the one in green is the one I want to actually graph, right? So let's say you had x minus 2 squared plus 3. Okay, so now we have to look at 2 things. Okay, so remember, if you're graphing, think of the function f of x equals x squared, right? It's a quadratic, right? And so we got to compare that. So let's say you had, the wrong color. So if you normally had f of x equals x squared, again, that's going to look just like this, right at the origin. This is the function that we're graphing, right? But the minus 2 inside the parentheses and the plus 3, those are 2 shifts. One's a vertical shift and one's a horizontal shift. So which one is the vertical shift, up and down? Okay, remember this is your y and it's your x, right? So this one here, okay, the plus 3 right here, that's going to be your vertical shift. So it's going to shift 3 units up. And then this one here, okay, is your horizontal shift. And that's basically 2 units to the right. Okay? So we have 2 shifts here. Okay? So how do we do that, right? Well, think about it like this, what is a vertical shift? A vertical shift is, consider it outside of the function, okay? And think of the parentheses, x minus 2 is inside the function. So we have x squared in black, this is what it would normally look. But if you're doing x minus 2 squared, then that's a horizontal shift, and that's going to shift to the right, okay, to the right 2 units, okay? So in blue, if we shift it, so we match it up, okay, so let's do it in blue. Let's do the horizontal shift of 2 units. So the origin, the vertex is at 0, 0 originally, and then we go 1, 2. And that's what it would look like if I did a horizontal shift to the right. Okay, so this would look like x minus 2 squared. Okay, and the 1 in black is just x squared. Okay, now in red, I put vertical shift. So if you want to do a vertical shift, then again, 2 units to the right in blue, and then from there we go, how many units up? 1, 2, 3. We go right here. 3 units up. And that is my final graph that we want. And that's going to be x minus 2, because it shifted 2 units to the right, and then it went 3 units up. And that's my final resting place in red. So consider the parabola in black, right, is where is my original function, f of x equals x squared. And then I did x minus 2 squared, so that means I'm shifting it 2 units to the right. And then not only that, I did x minus 2 squared plus 3, which is a horizontal shift up. And these parabolas are right side up because the a coefficient in front of the a is right here. That's a 1, positive 1, right? So positive is up. If that were negative, then all these would be down, upside down. Okay? So really that's the basics of a shift, okay? Let's do one more on the next slide, okay? All right, so here we go. All right, so look at this one, okay? Whoops. Okay. So again, what is my function, right? It's something squared. So that's a quadratic. So my original function is, it's going to look like this, right? F of x equals x squared. And that's what it would look like, okay? So it would just be a parabola going through the origin, okay? So, and it's going to look just like this, right? Again, I'm going to do all of it so you can see the steps, okay? But once you do enough of these, you won't need to draw the original graph. You can just do it. You'll just know, oh, that's a parabola. Okay, well, that goes through the origin. It's either positive, it's right side up. If it's negative, it's upside down. And then you just look at the shifts, all right? So let's look at the shift inside the parenthesis. You notice that it's right here is going to be a horizontal shift. Of 3 units. And that's going to be 3 units to the left. So if we do that, then we take the origin, 0, 0, and go 1, 2, 3, and that's right there. Okay? So remember, the 1 in black is my original function, x squared. The 1 in blue is my shift to the right, which is basically x plus 3 squared. But I know I not only want to shift it 3 units to the left, I'm going to look at the horizontal shift, the vertical shift, and see this right here? That's my vertical shift. And that's going to be 4 units downward, okay? So 3 units to the left in blue. Now from there we go 1, 2, 3, 4, and then there is my shift 4 units down. So you notice my original vertex is at 0, 0. Then my vertex was -3, 0. And now that vertex shifted 4 units down. So now this is my new location of the parabola. So my vertex is now, what is this point, right? Got 3 units to the left, and then we got to go 4 units down to get to that point. So you can identify the vertex in each possibility, you know what I mean? So when you graph a parabola, you know the vertex, you know, and you also know the line of symmetry, or the line of symmetry is going to go through right here. Since this is the final resting place of the graph, then my line of symmetry is that vertical line going through that parabola at -3, -4. You notice to the right of that orange line is half of the parabola, and then to the left of that orange line is the other half. It kind of divides the graph into 2 equal parts, you know. So the axis of symmetry, okay. So again, I'll write it in this color, right? The axis of symmetry is going to be x equals, again, this vertical line is going to cross the x-axis at -3. So it's going to be x equals -3. So it gives you the line of symmetry, and it also gives you the vertex. So let me label that as the vertex. Okay? And that's it. That's all there is to it, okay? So remember, horizontal shifts are left or right. So if it's positive, then it's to the left. If it's negative, then it's shifting, you know, so many units to the right. Vertical shifts, you just read it as you see it. If it's negative, it's down. If it's positive, it's up, because it's outside the function, okay? And that concludes the video on the basics of graphing a quadratic equation. Thank you so much for watching, and I hope this video was very helpful to you.